All right, AB Calculus. This is your second question for the day. It's 2005. Question number 2. If you haven't tried the question yet, pause the video, try the question, then come back and look for help. Or you can always, of course, tune in for part A or part B, C, depending on what you need. All right, so here we have a problem where the tide is being removed from Sandy Point Beach at this rate. Now, this is an entering rate, leaving rate question. So if you took the notes on the board before with entering rates and leaving rates, this is how fast it's being removed. So it would match up with LT from our notes before. And then this right here is the rate that sand is being pumped onto the beach or entering the beach. So this would match up with ET from our notes before. So if you look up all the notes from before, you should learn some stuff here. Okay. Well, let's go ahead and try the parts. So very first one is part A. How much sand will the tide remove in the 6-hour period? All right. Well, this right here, just to show you, is the rate that sand is being removed in cubic yards per hour. So cubic yards per hour. And if you take the area underneath the rate, it will give you the net change in the antiderivative. So it will tell you how much has been removed. So if this rate tells you, if this is the rate that sand is being removed, the area underneath the rate tells us how much is removed. So part A, we're simply going to take the area underneath this. I'm just going to call it RT. That's a lot quicker than writing all this out. You can write all this out as well. Just don't forget your DT and have parentheses around it. And from here, again, if you've plugged it in your calculator, I plugged this one in Y1 and this one in Y2. I can use my hotkeys. So I just hit Math 9 to pull up the integral from 0 to 6. And then alpha trace, use my hotkeys to put Y1 in there. Or you can just type out the equation. Anyway, so here we get the answer of 31.8159. That's part A. Part B says write an equation for y of t for the total number of cubic yards of sand on the beach. So in this question, they want to know how much had been removed. Nobody cared about how much sand was there, just how much sand had left. So again, I have a water bottle. I don't have a water bottle. I always have a water bottle for my examples. No, I don't need a water bottle. Thank you, hon. I have a cup. Great. So remember, think about it this way. We have a cup filled with sand, and we're pouring it in at some entering rate. That's S of t. And then there's some leaving at some rate. That's R of t. If you want to know how much water, how much sand's on the beach, well, first thing you need to know is where did it start at? So we need our initial point, and then we need to add to it the amount we added. The area underneath this will tell us how much we added and then how much we lost. So here's my water level, or sand level. How much did I add to the initial, and then how much did I subtract? And that's going to get us to the answer. So we want to know how much sand there is at time t, and they're calling it y of t. Now this matches up with your notes when I called it a of t. A of t is the same as y of t if you go back to my notes. So y of t, it starts off with the initial, how much sand's on the beach to begin with, and that was 2,500, plus how much entered. The area underneath the entering rate will tell us how much entered from time 0 to time t. Now, here's where things get just a little sneaky. If you're going to say from time 0 to t, how much entered, from time 0 to whenever we stop, if we put a t here, we can no longer use a t here and a t here. We've got to pick some other variable. It can be anything in the world. If you look online, they use X most of the time when they need something. I've mentioned before, you can even put happy faces there. It doesn't matter. So that's how much you started with, plus that's how much you gained, minus, and then the area underneath RT tells you how much you lost. But again, instead of RT, I'm going to change that to an X. If that's a T, those can't be T's. And that's your answer for part B. How much do you have at some time T? The initial plus how much you gained, minus how much you lost. Alright, part C says find the rate at which the total amount of sand on the beach is changing. So find the rate at which the total amount of sand on the beach is changing at time equals 4. Okay. Now the rate that the sand is changing is basically could be called the net rate. Okay, the net rate is simply the entering rate minus the leaving rate. Or in other words, entering rate here is S of t minus the leaving rate is R of t. That would tell you the rate that sand is entering the beach and leaving the beach, kind of taking both into account. It says find the rate of the total amount of sand on the beach. Or if you think of this as an equation, this equation is the total amount of sand on the beach, and we could take its derivative and find y prime t by taking its derivative. This is the amount of sand, its derivative is the rate that the sand on the beach is changing. Well, if I take the derivative, well, the derivative of 2,500, or any number, is 0. Here, if I take the derivative destroys the antiderivative, and the t would jump in. Minus, and here the derivative destroys the antiderivative, and the t jumps in. S of t minus R of t, and you'll notice that's the same thing we have here. So to finish the problem, we want to know the rate at time 2. So is it time 2? It's time 4. So we're just going to plug a 4 into both. Now, remember, I put this in my calculator in y1 and y2. But anyways, I need to put a 4 here, and then a 4 here, and then subtract the two answers. If you are not using hotkeys, you have to be very careful. Again, I used hotkeys. I put this in y2. So I'm going to use alpha trace, put parentheses, put a 4, minus, and then I'm going to go ahead and put a 4 into R of t, but R of t is in y1 in my calculator. And this will give me the answer. If you don't have it in your calculator and you're typing it in by hand, S of t, you have to put a 4 here, minus, and then here's the big problem. You have to make sure that this minus sign belongs to everything, all of R of t. Make sure it distributes or belongs to both here. So 2 plus 5 sine of 4 pi 4 over 25. And again, all I did was I took the t and replaced it with a 4 right there. But again, I'm going to do it this way because I can get it done in about 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, no, a little bit less, 9 seconds. I'm sure everybody's so proud of me. Like, you're so awesome, Mr. Pikett. How'd you ever do that so quick? Okay. Well, now that I'm bragging, let me check on mine and make sure it's correct. Yes. Okay, and let's see, do they want units with this? They don't ask for units, but if you wanted the units, it's these two units being subtracted, so it's just yards cubed per hour. All right, part D says find the time at which the sand is at a minimum value, and then find this minimum value. Okay, well, some questions here. When can you have an absolute minimum or an absolute maximum? Endpoints, critical points. So, at the end of the day, the most amount of sand could be at the end, or the minimum amount of sand could be at the endpoints at time 0. We already know that's 2,500. Or the endpoint at time 6. Now, y of 6, I'm talking about this equation here. And I can find out how much is in there at time 6. I'm just going to put a 6 here and a 6 here. Remember, these are already in y1 and y2 and y1 in my calculator. And I'm just going to type them in. I'm going to say 2,500 plus how much entered. So math 9 from time 0 to 6 of this. Again, that's in y1 in my calculator. Y2, sorry, in my calculator. So alpha trace y2. And then minus math 9, another integral from 0 to 6. And then what was in y1 in my calculator. And I get 2493.2766. Okay, so those are my endpoints, but we could also have a minimum at critical points. Remember, if I were to think about how y of t would look, maybe it looks something like this. Woo! I don't know. At endpoints, you could be at an absolute max or critical points. Or minimum, sorry. Critical points. Critical points are where the derivative is equal to 0. Well, critical points. How do you find the critical points? We've talked about this before with the water example. Entering rate, leaving rate. If things are entering faster than they're leaving, the amount goes up. And then it starts leaving faster than it's entering, the amount goes down. So when they were equal, it stood still for a minute at a maximum. Now, if the leaving rate's faster, it's going down, and then it switches and the entering rate's faster and the amount's going up. Well, right here, that minimum is, again, when the entering rate is equal to the leaving rate. Now, remember I said you could also think of it as a critical point as where the derivative is equal to 0. Well, here, this is the derivative. If you set this derivative equal to 0, you see how you can add the RT to the other side, and it's when S of t and R of t are equal. The entering rate is equal to the leaving rate. So how am I going to find when this equals 0? Well, I can graph these two, and then just find where they intersect. I already have them in y1 and y2 in my calculator, so I'm just going to hit graph. I'm going to make sure my window, oops, I didn't like that window, it goes from 0 to 6. And see how this goes. So I'm graphing my windows from 0 to 6, and I find out that they seem to intersect twice. Nope, only once. They look like they intersected twice, but the only time they intersected was at time 5.1178. And again, I'm going to go ahead and take that time, that 5.1778, and I'm going to take that number and plug it here, and plug it here, and type this out, 2500 plus, from 0 to that 5.178, and 0 to that 5.178. So I'm plugging both of those in to find the amount at that time, and I get 2492.3694. And if you look at the three of these, look at these three values. This is the least amount of value. So at time 5.1178, the least amount of volume on the beach is this. So you'd say at time this is the minimum. Alright, that's parts A, B, C, and D. It's a fun question. Hope you understood it. Hope you enjoyed it. Make sure to see my other video. My last video of the day, Lewis is going to help.